In this video, I am going to talk about rotations in 3D engines and the problem of gimbal lock. So when you want to represent a rotation in a 3D world, in a 3D engine, you usually either pick a matrix or a quaternion. And you might have heard that it's better to use quaternions because they have this benefit over matrices, that with quaternions you can avoid the problem of gimbal lock. And in this video I am going to show and demonstrate that this is not the case, and that quaternions are not at all related to gimbal lock. And I will show where gimbal lock is actually coming from and how we are avoiding it. Yeah, so I will be presenting everything within the Unity engine. So here I built myself a 3D object which is supposed to be showing some coordinate system. It will be easier this way to be seeing what is happening. So this object is composed of this cubical red mesh representing the x-axis of this coordinate system, and we also have this this green box which represent the y-axis, and finally we have the blue cube which represents the z-axis. And now I'm going to show how you can rotate this object within Unity. And in other 3D packages or 3D engines, it probably works in a very similar fashion. All right, so maybe let's do it this way. All right, so here we have the x-axis, y, and z. And over here, I'm having a transform component of this 3D object, and this component has properties position, rotation, and scale. So we are interested in the rotation property. This rotation property has sub-properties, which are rotation around the x-axis, y-axis, and the z-axis. So let's see how it's working. So I will be now increasing the value of the rotation around the x-axis. So as you can see, this object is indeed rotating, and now when I'm reaching 360, it has rotated around a full circle. Yeah, everything's working as expected. And now when I'm changing the y property, it's rotating around the y-axis, and also I can rotate around the z-axis. All good. Yeah. The other way to rotate an object is to use so-called Gizmo. It's a tool where you can rotate the object without specifying concrete values, but rather by rotating around along some plane. So right now I am rotating using Gizmo, rotating this object around the z-axis. Let's revert this, and also I can rotate around the x-axis and also around the y-axis. Yeah. Now one more thing which I want to show before we deep dive into the gimbal lock problem is in Unity. I'm going to now change to the translate component where it's showing this 3D coordinate system. And yeah, so now I'll rotate this object, and as you can see, this gizmo is staying the same because it's basically representing the global coordinate system of the scene. So it basically matches what is over here. But I can switch this to showing local coordinate system of this object, and I do it by clicking this global button over here. Yeah, and right now this gizmo will be aligned with the object because it's now oriented in such a way that it is being affected by the local transformation of this object. So when I will be rotating it, it will follow, the gizmo will follow the object. Yeah. All right, so let's go back to the beginning. And now I am going to show you what the gimbal lock problem is. So we have seen before, I demonstrated it before, how rotation works around the x-axis, y-axis, and z-axis. All good. So now let's set the x rotation to be a specific value of 90 degrees. Okay, good. And now what I'm going to be doing is I'm going to be increasing the y component of rotation. Okay, everything seems just fine. The object is rotating around the global y axis. Not local, but global, because if we switch here to local, we see that the local y-axis points over here. So, well, that's why we have this coordinate system mesh to indicate this. So let's go back to global, and yeah, so it's rotating around the global y-axis. All good. Let's go back to 0, and now I'm going to be increasing the z rotation, which, as you might expect, will make this object to rotate like here around the global, around this global z-axis. And surprisingly, it does not do that. Instead, it's rotating around the global y-axis. It's doing exactly the same as rotation around the y. So rotation around z and y does the same thing. And this is what we call a gimbal lock problem. And this problem is that we simply have lost 1 degree of freedom. With rotations in 3 dimensions, we have, well, because we have 3 dimensions, we have 3 degrees of freedom. But here, under these circumstances, with being rotated around 9 degrees around the x-axis, somehow we lost the ability to rotate around the global z-axis. We cannot anymore do that. And okay, so how could we solve this problem? Okay, so let's say we heard that Quaternions indeed solve the problem of gimbal lock, and we write code which will use Quaternions. That's this one, it's this one, yeah. Okay, so what I did over here is that I constructed a series of 3 Quaternions. The first one is the last one in the line, because transformations are applied in Unity. Transformations are applied from back to front. So this will be the first transformation that will be performed. So this transformation does rotation around the z-axis. It constructs a quaternion that rotates around the z-axis, and then it's multiplied by a transformation which does rotation around the x-axis, and then it does transformation around the y-axis. So we are now going to use that script, and it will override the Unity's rotation system. Okay, so let's select it, and it's over here. It's turn on. Okay, I'm going to play this now. Okay, so let's see if it's working. Yeah, so as you can see, yeah, when I'm trying to change this value, it does nothing, because Unity, because I am overriding the rotation value over here with my component. Which specifically I typed quaternions. I use quaternions to perform the rotation, to construct the rotation. So it is rotating around the x-axis, good. It's rotating about the y-axis, good, and around the z-axis. All right. So let's now do this thing again we did before. So we have the rotation around the x-axis, and now around the y-axis, it indeed works. Okay, and now big time z-axis. And as you can see, it's still not working. It's doing exactly the same thing which changing of this property did. Nothing changed. So even though we used quaternions, we constructed a series of quaternion transformations, it did not help to avoid the gimbal lock problem. Even though we used quaternions, we are still experiencing the gimbal lock problem. And that is because the gimbal lock problems is the result of applying a series of transformations. And here we are using, we are composing the whole rotation of the whole object using a series of three rotations, of three transformations. So it doesn't matter whether we use matrix whether we construct three matrices representing those rotations around each particular axis and concatenate those matrices into one composited rotation matrix, or whether we use quaternions for that purpose. It does not matter. The problem is that we are applying a series of rotations. So I thought that maybe if instead of specifying directly those quaternions, three distinct quaternions and concatenating them, I thought that maybe if I used Unity's Euler method, then I could solve this problem. So let's see how it's going to turn out. Let's run it. Okay, let's move here. Okay, 90, again, rotate around the y-axis. Okay, and z-axis, same thing. So no, it didn't solve the problem because likely this method inside likely is performing something, this code similar to that one. So we are doing the same thing. And this approach to constructing rotation is called Euler angles, hence the name Euler. So the Euler angles, this way of representing rotation it works the same for both matrices and quaternions. The idea is simply to take some mathematical object which represents rotation and do a series of multiplications and concatenate all those transformations together. And this is what Euler angles mean. Right. So if this gimbal lock problem is such a big thing, because apparently, certainly now you have seen that it is a big problem. Have you ever heard about artists or level designers, whoever, who would be complaining about this problem? I don't think so, not really, and that is because people rarely specify rotation using this triple, the Euler angle triple from the transform component. Most often, people use this rotation tool, this rotation gizmo, to rotate the object. And here, let's just see again the problem. Let's just again type in the 90 degrees rotation around the x-axis. And as you saw before, we had problems with rotation to rotate around the z-axis, right? which is over here, because right now it's rotating around y. But using this rotation tool, we can rotate around the z-axis without any problem, right? So I'm rotating around the z-axis. I can rotate around the y-axis, and I can rotate around the x-axis, no problem. And that's not all, because I can even rotate around local axes without any trouble. So let's use again the global rotation, and make some funky transformation. See, I have this object like this, and yeah, let's do again the global rotation. Yeah, it works very well. It rotates around the y-axis, now around the global x-axis, and now I can switch to local rotation. So when I'll be dragging this yellow arc, sorry, the green arc, it will be rotating around this cube. Yep. Same for x. Same for z. And notice something interesting. When I'm doing this rotation right now, what is happening to this triple, to Euler angles? I am rotating around a single axis, local axis, and all those values change as if I were rotating around all of them at the same time. What happens if I do this globally? Also, I'm experiencing rotation around all three axes, even though I'm right now certainly rotating only in the global x-axis. So the reason why those values show up this weird way, in this weird way, and they are all changing, is because they are showing us what are the values that would be plugged into each of those transformations, so that it would result in this particular setup. So if I plug this value, x value, into here, and if I plug this value over here, and if I plug this value over here, then out of this composition, I would I would end up with this particular 3D setting. So using Euler angles, it is perfectly possible to achieve any orientation and any rotation of an object. It's just that it's not always easy to accomplish because of the gimbal lock. So let's right now let's put identity transformation to this object, and we will now see something different. We will see how this gizmo object, this gizmo rotation, how it's implemented. So let's hide this one. Okay, so here I have another 3D coordinate system mesh with a different script attached called rotation gizmo emulator, and this script emulates what this rotation tool does. So let's see how it's working. So we'll first run it and switch back to scene, and yeah, and now I will toggle the X rotation around local X-axis. Okay, so it's rotating. Now let's do rotation around local Z-axis. As you remember, the blue cube is local Z-axis. Yep, it's working. And around the local Y, also working. And again, as you can see, the unity's rotation Euler angle triple is showing some, is changing all of the three values. We can also do rotation around the global axes. So let's do it around the global Y. Right, global Y is going up there, and it's rotating around us. So it's doing exactly the same movement as the rotation tool. So let's see how it's actually implemented. Yeah, it's over here. So let's first consider maybe the global case, because global case should be slightly maybe easier. It's over here. So first, what we are doing in this update method is we are reading the current rotation component, the rotation quaternion, because Unity internally stores rotation using quaternions. So we are reading the rotation, and then we are checking if the X bool is toggled true, and if it is, then what we are doing, we are taking the current rotation and we are multiplying it or applying to it rotation constructed with this method called quaternion dot angle axis. This essentially constructs a quaternion that rotates around a specific axis, a specific number of degrees. So in this case, we are rotating around the global x-axis with some, and as angle we pass the speed multiplied by delta time. And we do the same thing for the remaining axes, for y and z. And when it goes through the local path over here, we just read the transforms component right vector, up vector, and forward vector. These three vectors basically simply represent they represent those vectors. They are these three vectors: the local forward, up, and right vectors. So this doesn't exhibit the problem of gimbal lock because it's only one transformation. And what's more important is that we can construct the angle axis transformation for a matrix as well. So this way we can have matrix transformation without using any quaternion. We can have matrix transformation which also doesn't have a problem with gimbal lock. So as you can see, it doesn't matter whether we use a quaternion or a matrix. Gimbal lock is not at all related to using either this or this. Gimbal lock is the problem which comes from compositing a number of rotations, and not the problem of using either a quaternion or a matrix. So one question you might be asking yourself now is why you would use quaternion over a matrix then? Because all 3D engines use quaternions, so there must be some other reason. If not gimbal lock, there must be some other reason why they would be doing it, and they do that probably because of at least two things. One thing is that quaternions require only 4 floating point values to store, whereas to represent a 3x3 rotation matrix you need 9. So using a quaternion is memory saving. That's one thing. And the other thing is that with a matrix, with a quaternion, you can perform a spherical linear interpolation, which is extremely useful especially for animation and movement in general, where you can perform, basically interpolation between poses of characters, etc. it's more difficult to achieve that with a matrix. You might be wondering now why Euler angles are used over here to represent rotation, even though we have learned that they are the reason standing behind the problem with gimbal lock. The reason why Euler angles are still used, I think, is that they are, even though they have the shortcomings, they are significantly more user-friendly than matrices or quaternions. For instance, if you wanted to display a rotation matrix over here, you would need to display 9 values, because that's how many a 3x3 rotation matrix needs. For quaternions, it's only 4 values, so it will be only one more value than what is over here. But still, quaternions, their x, y, z, and w components, they don't map very well to rotation around its specific axis. And they are also, just as a matrix, quaternion is also significantly less user-friendly to display than Euler angles are. So even though Euler angles don't always what they represent, triple represented, even though it doesn't always match exactly, it's not doesn't match exactly what is presented in the scene, how an object is oriented or rotated. They are still a better way to work with than a matrix or a quaternion in terms of user friendliness and typing in specific values. So that would be it. If you like this video, please like it, leave a comment. Maybe you could add something to this discussion, point out something something important that I might have missed, and we could talk about it. Again, thanks for watching, and see you.